What's up, Raiders? Just want to talk a little bit about slope-intercept form equations and how you can kind of interpret them and graph them. This isn't designed to cover everything. This is really just to kind of go along with the Odyssey-aware distance lesson that you have on this. So first things first, anytime we talk about a slope-intercept form equation, that means generically it's going to have the format y equals mx plus b. But let's break that down to get each part. Notice the term is slope-intercept. There's two parts of the name. There's two critical things you pull out of the equation. So anytime an equation's in slope-intercept form, your dependent variable, whatever it is, generically y, will depend on what the value for x is, the independent variable. So first things first, your equation to be in slope-intercept form, you have to have your dependent variable y isolated all by itself, y equals. Then from there, whatever the coefficient in front of the x is, that's attached to it, that's multiplied by it, that is your slope. And that's got a couple different terms and ways to identify it. In the equation, it's m, and we refer to it when we do the graphing, and we'll do that in a little bit, is the rise over the run, where you take a look at your graph and you look at how much to get from one point to the next does your graph rise up, and then how much does it run over to the side. So that's the slope part of slope-intercept. And then the the constant that's all by itself, that's the b, that's the y-intercept. So collectively, these two parts of the equation are where the y-intercept name comes from. And the y-intercept is where your graph crosses the y-axis. So here's an example of an equation that's in slope-intercept form, y equals 3x plus 2. The slope, in this case, would be 3. And then the run, so that's the rise over the run, the slope is 3. And then the y-intercept, where it crosses the y-axis, is 2. So just to address a couple things here, what qualifies as being in slope-intercept form? Well, as soon as you see the y equals mx plus b, some people, understandably so, kind of think you automatically have to be adding. But you could have something like this. You could have y equals 3x minus 2. This is still in the slope-intercept form. This is still your y-intercept, the plus b part, because really negative 2 can be rewritten as plus negative 2. So it could be y equals 3x plus negative 2. So it still really fits the format of y equals mx plus b. So in this case here, when you have a subtraction sign there, it really just means that, again, that's the y-intercept where the graph crosses the y-axis, it's going to be at a negative value. Now the order of it can change. Yes, it's written as y equals mx plus b, but if we took this equation and did y equals 2 plus 3x, that doesn't mean that the first thing you come to on the right side of the equation, that doesn't mean that's the m. That's still your constant. So this would still be the b, and then the coefficient in front of the x would still be the slope. And then you can have a situation where you have an equation that can be put in slope-intercept form, but it's not yet. You have to isolate the y. So in this case here, we're going to subtract 4x from both sides. So you have 2y equals 12 minus 4x. Now notice we still haven't isolated y and gotten it all by itself because it's multiplied by 2. So the inverse of that will divide by 2. And again, golden rule, whatever you do to one side of the equation, you got to do to the other. So now we're getting into the format we need for slope-intercept. Y equals, now take each term here and divide it by the 2. 12 divided by 2 is 6. And then don't forget the sign here, negative 4x divided by 2 is negative 2x. So you can leave it like this. Here's your b, and here's your m. But again, if you prefer to keep it as traditional as possible in the y equals mx plus b format, then you could rewrite it as y equals negative 2x plus 6. And then a couple other situations that can come up. You can have a situation where you feel like, hey, y equals mx plus b, I don't have a b. What if you just had this, y equals 3x? So it looks like it doesn't fit the y equals mx plus b format because you have no plus anything. Well, really what that becomes is y equals 3x plus 0. So your y-intercept is just 0. And when it comes to doing graphs, as we've done these examples, when you have y equals 3x plus 2. If your slope is a 3, when we get to graphing in another video, that's going to seem a little confusing. If its slope is rise over the run, well, that's a fraction, but there's only one number. Really, you can look at it as y equals 3 over 1 x plus 2. So that gives you your rise over your run. All right, that just kind of goes over what truly fits the format of being in slope-intercept equation, and I'll do another video that shows you how to graph these equations. All right, Raider Nation, if you have any questions, like always, send me a question directly through the help tabs in Odysseyware, or you can get me on the Remind app. Take it easy.